Hello, in this episode, we will look AWS Elastic Container Service architecture and deployment options. You can use Amazon ECS to manage and scale batch and ETL workloads and to build sophisticated application architectures on microservices model with minimized resource management overhead. Amazon Elastic Container Service is fully managed container orchestration service. It lets you run your applications in the cloud without having to configure and maintain the infrastructure. To ensure capacity demands are optimally met and maintain peak performance, ECS continuously evaluates and monitors memory and CPU. This data helps to determine an optimal deployment strategy for each container. ECS supports integration with several AWS services, including Identity and Access Management, Elastic Block Store Volumes, and AWS Elastic Load Balancing. ECS simplifies the management of containers, but it doesn't automate the entire process. Still, fine-tuning and customization are required. Several key benefits can be given as following. ECS eliminates the need to set up and maintain the infrastructure of Kubernetes clusters. Scheduling capabilities enable you to schedule services, applications, and batch processes. ECS is responsible for maintaining application availability and helps you to scale up or down as needed to ensure capacity demands are met. ECS comes with native integration with wide range of AWS services. ECS provides simple APIs that let you integrate with your CI/CD pipeline and your existing tools. In this sketch, you see Amazon ECS with containers running on AWS Fargate. Now, we will discuss the main components presented. Containers and images. Application components should be delivered as containers. Containers are created from read-only templates, called images, that are usually built from Dockerfile. Dockerfile is a plain text file that specifies all the components that need to run in the container. Images are stored in container registry and can be downloaded and run on the cluster. ECS task definitions. To prepare your application to run on Amazon ECS, you need to create a task definition. Task definition is a text file that describes one or more containers that make up your application. The job definition can specify various parameters for your containerized application. For example, you can use these parameters to indicate which containers to run, which ports should be open, which data volumes should be used, what Docker networking mode to use, and identity and access management roles. Almost everything you can run in a command line Docker command can be defined using ECS task definitions. ECS tasks and scheduling. A task is an instance of task definition running in a cluster. After you create a task definition for your application in ECS, you can specify the number of tasks to run on your cluster. The ECS task scheduler is responsible for placing tasks in a cluster. There are two primary scheduler strategies. The replica strategy places a desired number of tasks in your cluster and maintains this number of tasks, restoring them if some of them fail. The daemon strategy places one task on each active container instance that meets the relevant criteria. ECS cluster. ECS cluster is a logical grouping of services, each composed of one or more tasks. A default cluster is always created. Additional clusters can be created to achieve resource isolation for different workloads. There are two ways to run cluster resources. Those are EC2 instances and Amazon Fargate. Container agent. The container agent runs on each container instance in ECS cluster. The agent sends information about currently running tasks and resource utilization to AWS ECS. ECS uses the agent to start and stop tasks as needed according to data collected by the agent. Now, let's go over ECS deployment options. EC2 instances can be used to run containers in ECS. ECS cluster can run in existing VPC, making it accessible to existing AWS resources running in that VPC. An alternative way to deploy ECS containers is Amazon Fargate. Fargate removes responsibility for provisioning, configuring, and managing EC2 instances, but some constraints imposed by Fargate. You must ensure that task definitions are stateless. You cannot attach block storage to container. Instead, you will need to use external storage services like S3 or traditional data service for persistent storage. In order to make value proposition of ECS properly, let's compare it with serverless AWS services, Elastic Beanstalk, and Lambda. One of the biggest advantages of ECS is the flexibility to change underlying EC2 instances. As the traffic or demand increases, you can change EC2 instances. Amazon ECS APIs are succinct and reliable. You can start and stop containers with single post requests. On the other hand, interventions such as terminating the instance that had deployment issue and recovery of Elastic Beanstalk will not be possible. When the Elastic Beanstalk deployment fails, there is no notification and further deployments will fail as well. Amazon ECS simplifies the management of containers and clusters, but doesn't fully automate the process. You are required to understand how ECS provisioning process works and continues to configure and scale your resources. On the other hand, AWS Lambda lets you code event-driven tasks that automate the compute infrastructure. Lambda enables you to define serverless infrastructure that doesn't require your intervention, aside from writing the code that trigger events. But it comes with its own limitations, such as concurrent execution limit and maximum runtime for Lambda function. In this short video, I tried to share some valuable insights about one of the important platform as service solutions from AWS. I believe that can accelerate cloud migration of enterprises for different workloads. Thank you for listening.